After this, we'll be going to an important law called as the Gauss law. Right? Gauss law is something like a substitute for Coulomb's law. Meaning Coulomb's law is applicable only for point charges, right? What if we have extended charges? You can apply Coulomb's law. I'm not saying you cannot do it, but it's a complicated process because you need to apply a little bit of math. Like you need to consider a small charge and integrate and all those things, which is not a part of the syllabus. So if you're for competitive exam, you can learn that. For CBSE, it's not there. So as a substitute of it, what they did is this Gauss law is proposed, right? So this Gauss law has three important applications, which is for an infinitely long straight charged wire, then we'll see for an infinite plane sheet, and for a uniformly charged spherical shell. So for all these things, what I've done is, even before we apply, see, this is something which I prepared with, this will not be available. I've prepared the algorithm, like the flow chart of how you are supposed to apply this Gauss law to any concept. Though they have given only 3 in the textbook, this concept, if you follow, you can apply it for anything. There are 7 steps, okay, which I will teach in the next class. So max, I don't think we can complete it by tomorrow, and I don't think we are in that urgency also. So by Monday, I'll complete it. Okay, that is one thing. There are some topics, right, which I could understand from your faces, or some faces which are at the back. Like sometimes you're feeling sleepy, I understand. One is climate is like that, and the topics are also slightly dry, right? So for those things, what I'll do is I'll give you pre-recorded videos, which will not be more than 15 to 20 minutes. I'll consolidate, condense everything and give it to you so that you can go through it multiple times. Before the class itself, I'll tell you. So for those topics, go through the concept, come here, so that I'll touch up on it once. So I will brush it up once, maybe for 5 to 10 minutes, then we'll do some problems, right? See, the major problem is with your question paper that has been changed. I've seen most of them struggling not with the concepts, with MCQs, assertion reason based questions, and the case study based questions. So I want to cut that faster. If that has to happen, we have to follow this process from the beginning. So it has only been 1.5 weeks, right? So slowly, what I'll do is I'm actually working on the pre-recorded versions also with better clarity. I'll record them and give it to you wherever the topics are big and time consuming, which I don't want to waste in the class. We get only 3 hours, no. So I need your cooperation in going through them and come. Please don't come up with any excuses because I'm also working along with you. Right? It is for you guys. So don't give any excuses. Don't say I don't have time or anything. Monday you're coming to class. Sunday at least spend 30 minutes for that. Take notes and then come. Be sincere. Okay. So that we can concentrate on the problems, because I didn't do problems this year. If you see, I've been only teaching, right? I didn't tell you how to apply the equatorial, the electric field due to the values that we have calculated till now. I have to teach that, right? So we need to save time. So this is one thing I wanted to just inform you so that you be mentally prepared. Okay. Anything else that you have in your mind? Any questions? Anything that you have learned but you didn't understand? Is everything clear? If at all you ignore the number of electrons that are lost or gained, they have same mass. That's an ideal situation. But speaking in reality, electrons' mass is also taken into consideration, because when you talk about atomic mass, whose mass do you take into consideration? You take only the neutrons and protons into consideration. But in reality, when a material is getting charged, it loses electrons. Electrons also have some mass, right? Though it is a very small value. It's 9.1 into 10 power minus 31 kilogram. Even if one electron is lost, that much mass is lost. So one material is losing that mass, one is gaining that mass. Because it's a small value, ideal situation we don't take into consideration. Why I'm stressing this much is that depends on the question. So you need to, you can need not take. Mostly they will not speak about mass at all. They will not speak, because we are concerned only about charge, right? So think about it. Anything else? Fine? Is everything fine? Okay, then shall we wind up? Those who are online, shall we wind up?
Yes, sir.
Okay, I'll see you.
Thank you.
Yeah.
Thank you.
Yeah. Electric? Okay. Phone இருக்கா?
Recording.
Phone இருக்கா? Photo எடுத்துறியா?